It was a big deal moving my big wheel to LI. Had a backyard, though shit moved slow. Caught a cat on the humble. What's up? What's up, kid? Got me memorizing flicks of the wild.
Hi, my name is Anil Nair and I'm an aerospace engineering student here at UCLA. And I'm going to help you by going over some math concepts and examples. Good luck.
For our second example, we have three equations, three variables, x plus y plus z equals 10, 2x plus 4y plus 6z equals 1, and 3x plus 5y plus 7z equals 11. So, again, I'm going to show you how we can write this in matrix form. Take the coefficients, so 1, 1, 1, 2, 4, 6, 3, 5, 7. And we're going to multiply that by x, y, z, and that's going to equal 10, 1, 11. So to actually solve this, we're going to put it in augmented form. So that is 1, 1, 1, 10, 2, 4, 6, 1, and 3, 5, 7, 11. And we just do the same thing as we did in the last example. So we have a 1 up here, which is what we wanted. So we don't need to scale that row. So now we want a 0 here, so we're going to take R2 and subtract 2 of R1 from it. This will give us an unchanged top row and an unchanged bottom row. And we get a 0 here, which is what we wanted. And then I'll get a negative 2 plus 4, which is 2. And then we get 6 minus 2, which is 4. And then we get negative 20 plus 1, which is negative 19. Okay, so now that we have a 0 here, next step is to make this a 0. And we do that by taking R3 and subtracting 3 of R1. This gives us unchanged top row and an unchanged second row. We get a 0 here. And then we get a 2 here. And we get a 4 here. And we get negative 30 plus 11, which is negative 19. So now we want to make this a 1. So our next, we're finished with this column. I move on to this one. And the way we do this is we take R2 and we multiply it by 1/2. And this gives us unchanged top row, unchanged bottom row, and our middle row is 0, 1, 2, and negative 19 halves. Alright, so now this is just a pretty mechanical process. Next step is we want this to be a 0, so we take R1 and subtract R2. This gives us unchanged bottom 2 rows. So the top row becomes 1, 0, negative 1, and 10 minus 19 halves. 10 is 20 halves, so 10 minus 19 halves would be, so 10 plus 19 halves. So we have 39 halves, I believe. The only place where you really get messed up on this is the arithmetic, especially when you get fractions. So check that later. So now we want to make this 0. And we do that is we take R3 and we subtract 2 of R2. And what happens here is top row is unchanged. And the second row is also unchanged. But now we get zeros all along the bottom. And that's okay. We can continue. 0, this represents 0 equals 0, so it's a valid statement, so we're good. Now, now we have it in reduced row echelon form. We can't make this a 1 no matter what else we do, so now we just convert this back. So we have x minus y, or x minus z, equals 39 halves, and we have y plus 2z equals negative 19 halves. And we don't have an equation concerning z, so we just say that z equals z. So we can write this as x equals 39 halves plus z, y equals negative 19 halves minus 2z, and z equals z. And then we just set, since z is, everything depends on z, we set z as a free variable. So we say like z equals t, and then we say that x, y, z equals 39 halves plus t, negative 19 halves minus 2t, and t, with t going from negative infinity to positive infinity. So what this is geometrically is our original 3 equations represented a plane, or 3 planes in space. And the planes all intersected. This might not be exactly how this looks, but they all intersected in a line. And this line is described parametrically by this solution.
Time to live, I got time